Internet Protocol, better known as IP, carries information to determine where to send the packet. It's heavily used by routing protocols. IP works on the network layer of the OSI model, is a connectionless protocol. That is, it doesn't establish a connection to transport the data. Instead, it uses TCP or UDP at the transport layer. Processes each packet independently, i.e., packets are not ordered to arrive at their destinations. And IP addresses have a hierarchy, because IP addresses are combined with subnetwork masks. We'll learn what these are soon, to create multiple subnetworks. We need an IP address to uniquely identify each network device. An IP address is like a landline number. In a city, you can tell where someone is from by the prefix in their phone number. An IP address has 32 bits and consists of two parts: the network part and the host part. A 32-bit IP address is written in 48-bit blocks. 8 bits make a byte, so an IP address will look like this. The network part tells us which network the IP address belongs to. This can be compared to a city or the area code of a telephone number. The host part uniquely identifies the network device. It can be seen as the last digits of the phone number. Take, for example, an IP address that's frequently found on local networks, 192.168.1.1. For this IP address, the first 3 bytes are the network address, and the last byte is the host part. One might ask, what determines the network part and the host part? Well, that's where the subnetwork mask comes in. The split between network part and host part is possible thanks to the subnetwork mask. In our example, 255.255.255.0, which can also be represented with a /24. The subnetwork mask, often shortened to subnet mask, tells your computer which part is the network part and which part is the host part. Despite the name it wears, it doesn't hide anything. It's thanks to a binary calculation that it's possible to create subnetworks based on the mask. Remember that the subnet mask indicates which part of the IP address is the network part and which part is the host. Let's see what an IP packet looks like. The protocol field contains the protocol that's being used over IP. You might very well find a transport protocol like TCP or UDP or any other protocol. In the source address field, you'll find the IP address of the device that created this IP packet. In the destination address field will be the IP address of the device intended to receive the IP packet. And the data field. This is where the data to be sent is placed. At this point, you don't have to worry about other fields for your... Now, back to our IP address, 192.168.1.1. An IPv4 address has a length of 32 bits, which gives us this in binary. As for us humans, this machine language is not easy to understand, so to make our lives easier, we'll put this series of numbers in blocks of 8 bits. 8 bits is a byte. With this 8-bit block separation, we can convert each byte into a decimal place. We'll start by converting from binary to decimal using this table. For the first block, we have 128 plus 64, which gives us 192. For the second 8-bit block, we have 128 plus 32 plus 8, which gives us 168. For the third block, we just have the last bit, so that gives us 1. And for the last block, it will be identical to the third. The decimal number is 1, which gives us the IP address 192.168.1.1. 1, 1.